So now I will show you how to write codes for this type of algorithms, the machine learning algorithms. So to begin with, I'll start with the linear regression algorithm. So I will write codes and show you how to write codes for linear regression algorithms, or more precisely how to draw, or how to find the best fit straight line for unstructured data points, for a lot of data points rather, having a mean. Well, so for that you have to launch the Jupyter notebook in your system. So my system is actually Linux Ubuntu 23.10 LTS. So here I've already opened the Jupyter notebooks on the screen of the computer. So for that, what you have to do is basically you have to go to a terminal and launch a Jupyter notebook, and you will basically be redirected to this type of interface. Now you can see here I've already opened it. So here I will write the codes for linear regression method algorithm. So for that I have to select the kernel. So this is IPy kernel by Python 3 that I will install here, I've said. And so I have to open the new notebook. Here I will write the codes. I will give the inputs here in these lines and these cells, and then I will get the the output also. So let's begin with, let's start. Let's talk about, let's assume rather 20 data points. So for that, let's assume 20 of our friends, that is me and 19 other friends, have 20 cards. So for that, according to the age according to how old those cards are, I can see the speed of the cars for a certain distance, right? So suppose 20 of us have different cars, and having different aged cars. Actually the cars is different, and then for a particular distance we have the speed of the cars. Okay, so we will write those 20 data points here in x-axis and y-axis. So in x-axis, in the x data points will be how old the cars are, and the y-axis data will represent the speed of the cars for a particular distance, right? So for that, and then we will find the linear regression. We will use the linear regression algorithm in that, and we will find the best fitted straight line for these data points, right? And then we will later on predict the speed of a 10-year-old car. Okay. So now let's start writing the codes. For that, firstly I have to import the libraries here. So let's write the codes. Okay, you can see in the screen here. Here I will write the cells. I will write the codes. So for that, let's begin. So for that, let's import the libraries. And the library that I will import is basically matplotlib.pyplot splt. So let's start writing the code. I'm writing it slowly so that you can follow me properly. So you can see this is I have imported here. I am importing rather import matplotlib.pyplot as plt. Now hit shift and shift plus enter. Okay, now let's go to the second cell where I will just mention the data points, that is xy points, and here x-axis the points will represent the how old the cars are, and the y-axis points will represent the speed of those cars for a particular distance, any distance we can assume, and for a particular distance. Now let's write the datas, random datas. Sorry, 2 equals sign. Okay, so the data are the age or how old the cars are, basically these data. One, 0, 10, 11, 8, 5. Okay. Now these are the 20 cards ages. Now I'll write the time taken to reach a particular distance. Not time taken, sorry, to the speed of the cars to reach a particular particular distance rather. So let's write the y points here, and these are basically speed of the cars to reach the particular distance. The distance for all the cars are same. These y points will designate the speeds. It's 102, then 86, 93, 102, Okay, so these are 20 data points. So basically, the x again for clarification, I'm saying that x points are basically the ages of the cars, 20 cars, and the y points are the speed of the cars for a particular distance. So there are 20 data points you can see on the screen here. So you can see on the screen, okay, these are 20 data points here. Basically the x data points will be, represent the ages of the 20 cars, and the y data points represent their speeds for a particular distance, right? So the 20 data points you can see, let's check it out once again. Okay, that's fine. Now shift plus enter. Okay, now let's plot this. Let's plot a scatter plot for these x and y data points. Okay, so for that I will write the code. Since I have the plotting, this library is basically matplotlib.py plot as plt. So I will write it plt dot scatter scatter function, that is x of xy. The coordinates will be xy. Sorry. Okay, now let's hit shift plus enter. So you can see the scatter plot here. That is basically the plot. The data points are scattered. Basically, you can see all the data points that I have already taken here. X, Y. The X means the the ages of the car, 20 cars, and Y means the speed of those cars for a particular distance. So you can see all those points in this X axis and Y axis, and this plots basically this X Y plane. You can see this structure. So this is a two-dimensional X Y plane, and XY, this you can see those XY plane containing those data points. Right now, let's write PLT dot show. Okay, so this is the idea, this is the things. Okay, now I will introduce a term called R, that is coefficient of correlation. So what is regression, linear regression? So linear regression is basically is used to find the relationship between the linear relationship actually. The regression term, so what is the meaning of the word regression? Regression means the term regression itself meant by the relationship between the variables, right? So linear regression is the linear relationship between the variables. So sometimes so normally in machine learning and statistical modeling, the linear regression is used to find the relationship between the variables. Okay, now the linear regression is linear relationship. So not all the time you will find all the data points having a linear relationship. So if you have a scattered data points, you have a scattered set of data points rather, then you have to find the best fitted linear relationship, linear or straight line between the data point that passes through the mean of the data points. So that's fine. So here I have already taken 20 data points, and you can see this. This is scatter plot. Now, if there are no relationship between the x and y coordinates here, or the two variables, then there will be no existence of coefficient of correlation. So what is coefficient of correlation? That is small r that we will introduce now. So smaller is basically the relationship between that tells us the relationship, how much it is correlated, that there is two variables that correlated with each other. Right, now let's get this done. So for that, let's start writing the codes again.